So, right, it's 20 past, so I'm going to crack on. Okay, so a very big logo for my company, or as in for the company I work for. That's because they allow me to spend time in work hours and have time off to do these presentations, and it's only because they allow that kind of thing that I can talk at a conference like this. The topic's Little Fluffy Clouds, and I'm head of engineering at Free Market FX Limited. Free Market is a fintech specializing in FX trading, based in London. And that's pretty much it that you need to know about that. I doubt anyone's hugely concerned about that. So I always like to try and do an overview of what the talk is going to be. You might have read the abstract in the agenda, but it's important that, especially when it's a room in a venue, that people understand what I'm about to talk about. And if they feel they don't want to stay, I am more than happy for them to wander off and go to another talk. I won't feel insulted or aggrieved or anything. It will be fine. So this is a talk where we're going to look at some of the strategies for cloud development as an overview, the kind of lift and shift that you might see people do where you had existing infrastructure either in your own building or in a data center, and you're virtually moving things wholesale from there into the cloud, whether that's RabbitMQ or Redis or SQL Server, and you're virtually duplicating how you had it on physical hardware or on the virtual machines you were using anyway. Platform as a service, which is shortened to PaaS most of the time. Some virtual machines you might use to do odd bits, but lots of cloud services. So lots of managed services, in fact. So that's what I kind of see as PaaS. Then you get the new mantra of 100% microservices. Everything's in containers. We're using Kubernetes for everything, Docker. It's amazing. We're really into microservices. We've got thousands of them, and I can't even know how many we actually have, but they're out there somewhere talking to each other. And then the other one you get is pure cloud of serverless, and we'll just cover that a tiny little bit. Then I'm going to drill into the PaaS services with an Azure focus, because kind of that's the system I'm currently managing as head of engineering and our dev team manage. I came from an AWS background previously, so it's quite a good contrast to see both. I've got the advantages. I've got the classic Microsoft point and click type demo, which is real. But that's the interesting bit. Although it looks like it's point and click and it works and it's like 20 seconds, it's very easy to set up. It actually is a very real feature that I find one of the most easy and cheapest things that you could possibly have. And then I'm going to get to the disadvantages. These are the WTF moments of the last 2% that you find you can't configure because it's a managed service and they don't allow you to go that deep. This is where you need your swear box. And if you use PaaS and managed services, that swear box fills up quite fast because you eventually hit things that you can't configure, and you just have to learn to work around them and cope with the fact that you don't get a free lunch. So, and I'll cover some of the workarounds we use at Free Market. Who am I to be able to talk about this? Well, I used to be an application architect at Huddle, working with Ian Cooper, amongst others, and Toby Henderson. I then became head of engineering. So there, Ian Cooper had started a whole monolith to microservice journey. By the time and we had a US and a UK data center. The first thing we did with the US data center is move that to AWS in the US, and that was very much a lift and shift. So where you would have had a SQL server which had a primary server, a secondary server, and a shared SAN, that's exactly what we duplicated inside AWS. So if you needed to failover SQL Server or do things like patch one of them, you had to know how to use enterprise management tools, fail over the server, make sure it all transferred over, then shut one server down as an active SQL Server, patch it, reboot, then handle it failing over all back. So that's what we were doing. So by the time I left, we had bits from the UK starting to go into AWS, and the very first bits of containerization were coming in. And Toby Henderson has kind of continued that journey over the 18 months or so since I left, and they're going more towards containers, but still in AWS. But I moved to Free Market FX. When I moved to Free Market FX, they had a mature Azure platform. Ooh, I can take that off. A mature Azure platform, and they were using lots of managed services. So Azure SQL databases, App Insights, App Services, and they've been writing natively on Azure for 5-6 years. So I had about 4 months in the office before lockdown. Joy. So as well as learning about Azure and working out how it all hung together compared to AWS, I managed to have a project which was to tidy up my garden. It used to look like that, where my child is playing basketball or netball. You couldn't even see the shed, and it took about 2 months to tidy it all up. By then, I'd kind of learned, I really knew about Azure by that point. We had a few meetings back in the office, then it was lockdown 2. Lockdown 2 gave a project of having the top of my house removed for a loft extension, which involved a skip being put in the driveway, which involved me having to get a Land Rover that hadn't moved for 18 years, repaired and back on the road. That's a 1983 Land Rover. For anyone who likes history, that was built when C++ first came out. That's how old that car is, or how old C++ is. And to get away from builders, I go cycling. Why is this called Little Fluffy Clouds? Because I like a band called The Orb. I heard a Peel session with that song on it. I painted T-shirts because I had too much time when I was at university. And if you want, you can go onto eBay, and it's very on trend to buy cassette singles now. And you can buy secondhand a cassette single of Little Fluffy Clouds from by The Orb. But I would go to Spotify if I were you. So, overview of cloud strategies. That's how I said I was going to start. So, lift and shift. I've classed this as large clouds. So this is large, chunky things that you're going to move. So this is where, as I was saying earlier, you've got virtual machines. You may have web servers. There may be complete Windows boxes that are running IIS. They may be smaller boxes that are running Kestrel type servers. You might have real database servers like Oracle or MySQL running on real boxes or on real virtual machines where you're managing all the clustering, the failover, things like that. There's no optimization for cloud when you start doing that lift and shift initially. You're really trying to replicate how you would have had it in a normal data center. You've got reliability in terms of the network is probably more reliable than a switch in a data center, but you're having to manage a lot of the reliability issues to do with scaling or redundancy because you're having to work out how it's going to handle, how it's going to work. And you might have latency issues you didn't have in a data center because, of course, cloud networks aren't always on, always reliable, so you have to be a bit more defensive. Your job is to provision virtual machines. You're selecting how many CPUs or relative CPU power they have, how much memory they have, how much disk space. And you're probably still having to handle licensing, patching, and system management and things like that. However, you do get complete control. Realistically, if you want more than one network adapter, you can have it. We were looking at a virtual machine in Azure, or a managed machine in Azure, a tiny one, and we couldn't add more than one network adapter, so we couldn't have multiple IPs on it. You get server level configuration to optimize performance, so you're able to tweak it because this box is owned by you and you're using it. You get to decide how it gets configured a lot harder. And you control updates, so there's no surprising compatibility when something gets patched and released. On the other end of the scale, we've got microservices, Docker, and Kubernetes. So this is the full microservice solution, thousands of containers or hundreds or maybe only tens, it doesn't really matter. But what you can do is start using trusted container-based images. You layer your applications on top. Kubernetes or similar orchestration helps manage the system. The downsides are a lot of people have found that Kubernetes isn't the easiest thing to manage. You get then service mesh products like Istio put on top to try and make it easier, or Amazon's managed Kubernetes service, and people are now writing layers on top of Kubernetes, whereas Kubernetes was the layer on top of Docker previously. So it's harder to manage local development environment. How are you going to have 100, 200 Docker containers on your local box? So by snapping them into smaller and smaller bits, you make it harder for someone maybe to have to develop or test end to end. And you've got network configuration of containers. So some things like Redis cluster don't like the default Docker kind of natting that happens to be able to provision IP addresses and networks. And you might have more certificate management. So that's tiny clouds. But what about nano clouds? Because of course this is serverless. So that goes to the nano level. Yes, it's still on a server. We all know that. But you only pay for what you use. Scaling is handled automatically. Someone's provisioning the runtime engines on your behalf and maybe provisioning lots of them instantly. So you can have 20, 30, 40, hundreds of things running at once. And then it collapses back to only a couple of things running. We don't get local storage, but then that's a good thing in a way. We get stateless processing. Obviously, you've got some state somewhere. You must have a database or something that's more PaaS-y than just serverless. And we have AWS Lambda, Google App Engine as Azure functions. So all the cloud providers do really nice function-based serverless now. But we're looking at platform as a service in this talk. It's not serverless, but it's definitely less server, if that makes sense. We don't get dedicated hardware, and failures may be transparent. Sometimes they are, sometimes it fails over really nicely, and you have no problem with failover. Sometimes you have to think about it and be more defensive. A lot of the stuff that you might have worried about in a data center is certainly taken away and is more redundant and less prone to failure. We don't have operating systems to worry about. There is an operating system, and we'll see that later. But you stop managing operating system versions and patches. You select things like, I want it to be Windows or Linux to run this in app service world, and it'll have these runtimes on for .NET or whatever. And after that, you don't care. Someone else is managing that. It's Windows. They will patch it. They will eventually come around your machines, patch them, and redeploy them for you. And scaling may be managed automatically. So some elements, it scales really easily. So we're going to focus on little fluffy clouds, which is PaaS, platform as a service. Should be a capital S, tut tut. The first example I'm going to go for this, and this was one of the nicest things, is I came to a company that had SQL Server, from a company that had SQL Server, being enterprise managed, enterprise clusters, and a SAN. So, and I came to a company that was using Azure SQL. Now, there are different versions of SQL Server in Azure. There is a managed Azure SQL where you get a managed instance. It's virtually all yours. You own the kind of server and all the stuff that goes on it. And you've got a higher level of flexibility. They offer you the ability to put SQL Server on your own virtual machines if you want, but that would seem a bit weird to me. And then there's Azure SQL Database. And Azure SQL Database is what FreeMarket were already using. And this is where you kind of say, instead of saying, I want a SQL Server, and then I put some databases on it, you say, I want some databases, and can I have a SQL Server somewhere over in that data center in UK South or EU West? And so you do get a server name, but it's a server that clearly, although you've got a server name that's yours and it's unique, that server is shared with other people. So you don't get full control over that SQL Server, but you do get full control over the databases that are running on it. So now Azure SQL Database and the managed instance of SQL give you two things out of the box. One is an up to 35-day point-in-time backup. This is really cool. This is, I would like to restore my database at some point from the last 35 days to this exact point in time. And Azure has been backing up the transaction log from your SQL Server, can replay all the transactions and take your database right back to that point in time. And that allows you to debug a customer issue if you need to look at the data at that point. If there is some data import job that maybe went wrong or should have run overnight and it failed, you can move that database to that point in time and run that back at that extract again. And also, it is trivial to switch on long-term backups. So when we were on AWS at Huddle, we had to think about backups. We had to put storage allowances, make sure we had enough storage reserved so that we could have all these backups go onto it. This was really an issue when you're in a data center and you actually have limited SAN storage, and it's quite hard to expand without paying a lot of money. Whereas in Azure, we can just turn on, please back up this database. I want to back it up on Friday for 5 weeks and keep up to 5 weeks, then keep the first Friday of every month, and then keep the first Friday in January for the next 10 years. It's that grandparent, parent, child kind of backup rotation. And that just gets put in blob storage. And the really nice thing is things like when you encrypt your database, which you can do, encryption at rest, the backups are encrypted at rest as well. And therefore, the whole thing is much nicer for your security. And all those keys that allow encryption are managed by Azure, and you don't have to think about it. And backups are protected from people deleting them who shouldn't. You also get geo-replication. So this is where you really get the advantage over being in a data center, because this is, I can say I have a database and it's in Dublin, which is North Europe. Well, I want to have a replica of this, so just in case that Europe region ever failed over in such a severe way that we would lose our databases. So we can replicate it to Western Europe in Amsterdam. And that is a case of a few clicks and your database is replicated. And I know it's a few clicks because for this talk, I set up an entire replication of databases between regions, and it was trivial and it took hardly any time at all, mainly because I had a really small database. But once those databases are replicated, it's incredibly fast. And these things are instantaneous updates, even though you're talking, I'm doing stuff in Dublin and the other databases in Amsterdam, these will be incredibly fast in the milliseconds type range. And we also get failover groups by having geo-replication. So that if we did lose a database server in one region, we can just fail it to another region and everything can just talk to that and your code shouldn't even notice. And we're going to look at that in detail in the next slide. So, and you also get a built-in firewall, something that SQL had. It's been optimized for Azure. So now we don't have our Azure database open to the entire internet, because that is a bad thing. We can put in known IP addresses and handle that and properly secure it. Oops, just take a drink of water. And you can have both local logins, the kind of local SQL Server logins, and you can have Active Directory logins. So if you've got Azure Active Directory, you can use those to log into your databases as well. So it's all nicely configured. There is a WTF thing though. When you're using Azure SQL database, you cannot have more than one system administrator. Well, strictly you get two system administrators. You get one system administrator that's a local login, and you get a second a system administrator that can be an Active Directory, Azure AD login. The really annoying bit is that if I had a server in-house, there would be, say, only the senior devs were able to make system admin type changes to the databases. They would have a separate login that gave them those privileges. That would not be the login they used in day-to-day use. The problem you have is with only one login allowed, you either have to do a generic login or you have to switch people in and out. And we're switching people in and out so that it's actually really obvious that that user logged in as a system admin, did some work, and it's all audited correctly. The only problem is, and it's why you have to get the swear jar out, put some pound coins in it, is when you remove someone from the being sysadmin on the database server and put someone else in their place, the person you've just removed loses access to every database that they previously had access to. So there is no clean maneuvering of this sysadmin user. So that's quite annoying. So we're going to take a look at failover groups, because I was talking about this at a user group in the chat amongst the members before the user group, the actual main presentation started. And I was just talking about how we'd done geo-replication and done this failover. And it was really easy to do. And I was doing it while I was just chatting to them, doing it with test databases. And they all were going, it can't be that easy. And I said, it really was. So failover groups is, we use geo-replication. So we happily said, you can have a database in Dublin, have it mirrored over to Amsterdam. What a failover group allows you to do is say, right, instead of talking directly to those database servers that we have, and you have a connection string for Amsterdam and a connection string for Dublin, what we will have is a DNS type name for your failover group. This is a generic name for your server. And at any point, Azure will switch which server that points at. So you can fail over from one center to another, and every client will just move across within seconds because they're using the connection string that just points to whichever is the live server. Standard kind of failover. And you get a separate read, write, and read-only endpoint. So we now have the ability to have apps where if they're doing reads, they go to the read-only endpoint, and if they're doing writes, they go to the write endpoint. We've also got failover, so we've got a really nice system for working this. And you can have it automated or manual. Automated failover takes about an hour of database trouble before it will flip over. That's because, and if you read the documentation, they're quite keen on not flipping a database backwards and forwards every few minutes because it's quite a heavy duty thing to keep doing. And you'll lose some data, possibly tiny bits of data in the meantime, every switch. And you've got support for multiple failover groups for a given server. And each can have a different set of databases. They've got to be of a similar plan. So there's something called an elastic plan where databases share CPU power and database disk space, and it kind of moves, allows it to be a shared pool of resources for all your databases. You can't mix that with a standard plan, and the chances are your disaster recovery site or geo-replicated site only has a couple of databases, so you probably got them on standard plans. But then again, we didn't have enough to really use Elastic properly, so we just moved everything to standard plans. So I'm now going to go into the Azure portal and give you a vision of what a failover group actually looks like. And get to the right browser. There. Hopefully everyone's switched. Yes, it looks good to me. So this is just the standard Microsoft portal. We can look at Azure SQL to see what resources we have. These are all just created on a pay-as-you-go plan. So when I look in here, we can see that I have some SQL servers as well as some SQL databases. The important bit here is that we have, why is my mouse gone a bit funny? That's not helpful. We've got a primary server, a secondary server, and we've also got one in Western Europe. And we have one database. Oh, that didn't click in the right place. Forgive me. My Bluetooth mouse doesn't like the video sharing, I think. Got it. Okay, so here we are looking at our database on our primary server. And what you can see is we have geo-replication as an option on the left. And you can see that this little database that I've got called Little Fluffy Clouds is being copied in UK South. That's the primary. That means it can be written to. And we're also copying at the same time to UK West and Western Europe. So we now have 3 databases, one in Amsterdam, one in London, and one probably in Slough or Reading, wherever UK West is. Now, the thing about that is these are all sat on this server on 3 different servers. So to see that, how the failover groups work, we go over to the server, which is here. And there's a menu option called failover groups. And I've configured one failover group. And when you go and click into that to have a look at what it's doing, what you get is a huge map of the world where half the time all your databases are right next to each other. So it's like watching, anyone who's watched Richard Osman's House of Games, it looks like people trying to put things on a map and get them in the wrong place. But this failover group has just our Little Fluffy Clouds database. It hasn't got 3. I geo-replicated 3 databases, but for a failover group, you've got a primary and a secondary. That's how they work. So you don't include 3rd databases or 4th databases into the group. So we can see that on the primary, we can it's online and we can write to it. And on the secondary, it's readable. If we go back to our configuration, you can see we get things like a server name that includes the failover group name over here. Oops, there. And then we get a read-only endpoint, which the only difference from that is it has the word .secondary in the middle of it. And that gives us our read-only endpoint for scalability. So how does that work in practice? Well, what we need to do is go not to that, to SQL Server. So you can see in this SQL Server, I have got the primary database, I've got the secondary database here, and I just accidentally disconnected the failover, but good example of what you can do. So connecting to it in SQL Server is just a case of connecting to that failover group name we had, and there you are, it's connected, it's in SSMS. So there's nothing weird about how this all works. So we've got a database table, and if we go and look at it, oops, we've got a database with one table called replicated table. It's got some data in it. This is not the healthiest schema in the world. I have not done any primary keys. I have done the shortest bit of text in the world, and it sorts in some random order, but you can see it's got the numbers 1 to 10 written in it. So I will close that down. So if I'm in the primary, and you can see here, I've got the word primary on there. So that's where I'm running this from. I can execute that. Oops. And I get my data. I can then possibly look at the secondary. So here I am in the secondary, it's UK West. I execute that, same data. And it will not surprise you at all that in my failover group, I also can execute it and have the same data. So if I'm on my secondary, remember it was a read-only thing. So I will try to delete a row in here and I get read-only. So I'm not allowed to edit that because it's a read-only database. If I go to my primary database, I'm happily allowed to delete that row, should be. And there it is, deleted. I can now check to see whether that has come through to all the others, and it did immediately. There is now only 9 rows in that table. Okay. So remember that when I executed this, I got told it was read-only. Well, all I need to do to fail over my database is press this button up here. It does do a warning that anyone who's talking to the database at the time may lose a tiny amount of data. So any sessions that haven't been committed will actually possibly be chopped off and lose a tiny amount of data. But I do a failover. I wait for the progress bar. And normally 20 to 30 seconds. And you may be saying, that's easy though, because you've got the tiniest database in the world. It has 1 table. It has 10 rows in it, 10 or 9 at the moment. That's going to fail over really quickly anyway. For God's sake, there's no way that that's a problem. And you go and you can take that as read. But when we do our regular failover tests at free market, we have a much bigger database, and it still only takes 20 to 30 seconds to try and fail over. So it may be taking longer with this database, bizarrely, because it's less used, and it takes longer to fail over a database that's not in use heavily than it is to fail over one that is in use heavily. But look, there you are. The secondary database server has become the primary, and the proof of the pudding is the fact that now I can delete this. And now I'm allowed to delete something from my secondary database. So that is secondary database server. So that has become the primary, the live database. And now back where I was allowed to delete something, should no longer be allowed to delete it. because it's now become a read-only database. Oh, silly me. Didn't select the right bit of text. I was trying to hold my delete in a comment so that I didn't accidentally delete things. Oh. Right, let's execute that again. And now I get told it's read-only. The interesting bit is when we were in our failover group, at no point our failover group has just been completely moved to the different server, and at no point was it unable to delete. So the failover group is always going to be sat on a server that allows me to delete things. And there you are. And if we're correct, that should now have been replicated so that 4 has disappeared from the list. And there you are. That's pretty much how easy it is to handle doing failover groups. I think that's pretty cool. And as an example of cost, this is using the cheapest database I could buy, which is 2 gigabytes in size, very low power, costs £3.65 in the UK, or no, £4.64 in the UK, but £3.65 in Europe, which means to have two 2 gig databases that can be failed over and are replicated costs you about £7, maybe about €10, or about €8-9, which per month is quite good to have a completely failover database. So I was impressed by that. And app services are pretty nice too. I was used to the original Azure where you had worker roles and web roles. Now it's all an app service and there isn't a worker role and a web role. And you can actually run services in the background by using things like Hangfire, which is only used for a few old things at free market, or end service bus sagas, which is what we use now, in order to run these kind of background services, as well as the web. The thing about app services is scaling is easy, but you are meant to scale out, not scale up. You're meant to have more web servers, not a more big, powerful web server. We're not trying to give money to Sun, where at one point Sun was the company that had the best web servers because everything ran on one box and they were incredibly powerful. We want lots of little boxes. So it does mean you have to be careful how you handle your services that really should be singletons, where they want to process things in order. But you also get some really cool stuff. You have slots. So it is trivial to configure things like a staging slot. Just shut up my phone. A staging slot and a production slot. So you can happily put a new release of code onto your staging slot and test it, have a URI to it, make sure it all works, and then just flick it to production. And it's just a tiny little flick and it'll be ready in about 20 seconds. The slots can also be used for A/B testing. So you can put 10% of your traffic going to one place, 90% to the other, and the different code bases and see what the reaction is by your customers. And you can even set up specific customers to route to specific slots. And these are really handy as well in development because you can have a branch of code on a slot, run it, and it just talks with the same configuration values, the same setup, and it makes it really easy to test. So we don't need lots of VMs with lots of Windows servers, with lots of IS that all have different versions. These are just trivial to create and then rip down. It's still a virtual environment with a command line, and hilariously, you can actually get to the command line. So if I go to my portal and I go to my app service, we can move down and go to the developer tools, go to console, and unbelievably, you can do a list of directories in your www root folder. You can actually edit things in there or delete and load things. You can even go to the root and you can see that there is program files x86 available, which is kind of weird. You can't do a lot in here. because clearly you're on a managed service and you're not meant to be mucking about with it. But you get the feeling that in the same way that Docker has a kind of trusted container, your app service is a trusted Windows container with lots of stuff, including Python libraries are in there. I don't know if you noticed that, but there's Python 2.7 and Python 3.4. So, and your app service is then layered on top of it with all its configuration options. So, similar to SQL, backups are really easy to configure. So you can back up your slots and you just go, please back these up. Please back them up once a day, retain them for 30 days. I think that costs about 20 pence per month for free market because we don't have very fat app services and we don't back up the database with our app services. We happily just back up the databases as a separate kind of concept. So that's really easy to configure. App services have a single inbound IP, but by default do not have a single outbound IP. You remember you're on a shared resource here. So you kind of go to the app service. Here we are in the portal, and you can have a look at properties. And in properties, you will be told what IP addresses you might have. So that equates to something like that. So if you've got third parties who say, I need to validate who you are if you're talking to me, I need to know the IP addresses you're going to come from, you've got 6 IP addresses to give them. Well, you think there's 6, but there's an additional lot, which is basically a combination of any IP address that could possibly be coming from that region for those app services, and you have to hand that to your customer. Now, or third party. Now, handing 6 things to someone and say, please allow these all through, but handing about 50 or 40 of them is horrendous to say, please trust all these IP addresses, because they're clearly not just you. So some of our third parties, because we deal with banks and we deal with obtaining FX pricing, won't allow that. They want 1 or 2 IP addresses at most. So we had a workaround where we used a classic web worker that allowed you to have a fixed IP address. Then we then reverse proxied calls through it in order to get this IP address. It was a bit clunky, and the classic web worker is not the thing you wanted. We looked at NAT gateway and the ability to have everything going out via a NAT gateway, so it got a single outbound address, but not available until November 2020, when finally they allowed app services to have a single outbound address because you could hook them up to a NAT gateway. And now our life is a lot easier, and we're migrating things from old app service plans to new app service plans where we can hand out fixed IP addresses. So at least one of the areas where we used to have to use the swear box has gone away. Firewalls and VPNs. So I talked about firewalls on SQL. There's a load of other services that also exist that use these. On the SQL Server, there's actually a tick box saying allow Azure services. I would ideally not tick this if I were you. When you tick that, you are saying that you would allow traffic from any resource services hosted in Azure, not just your subscription, to access the database. You do have login and passwords, but in an ideal world, you would not allow everyone in your Azure region or your chunk of that Azure region to be able to access your server. So we used a VPN gateway. So they introduced this. I was chatting to Sahid. Yes, there is a WTF to do with failover groups when we did this. I was chatting to Sahid, who suggested I should look at it at NDC London last year. They just released private endpoints for Azure SQL, which allows you to have a unique IP address for your SQL servers, which can be hooked up to a virtual network that can be linked to a VPN gateway, and that allows you your developers to use an Azure client to do a VPN link and get to SQL Server, and then they get a note. You can allow all the IP addresses from that virtual network because you trust that, because you created that virtual network. The only people coming in are going to be people you've allowed into the system. This is the exact same way that you can allow app services to talk to SQL Server if they're all on the same virtual network as well. So it's that kind of evolution, but it does become harder to use SQL failover groups, because now if you're going over a virtual network to a private IP address, you are bypassing the kind of DNS lookup that handles failovers. So that was our WTF. So we decided actually one of the easiest way to handle access from devs or from finance or compliance or all the people who need to talk to a database occasionally is we would have an external VPN service that provide us with a fixed IP address. You would think in the old days we used to have the IP address of our office in London. Clearly no one is at that office anymore is the problem we have, and they're using MiFi units and 3G and moving between workspaces, shared workplaces to get out the house from the kids who are driving them nuts. And the problem with that is that IP addresses are always changing. So a VPN service was a much better solution for us. We also were trying to split our monolith type scenario into separate little services. So we're trying to split our API, and we're trying to do wildcard URI routing in an application gateway, so that anything that matches this path goes to this app service, anything matching this path goes to this other app service. We found you couldn't do wildcard URI routing because it was in private beta and we couldn't get into it. So that was a really annoying point where we were swearing quite hard about how can they not allow wildcard routing, because that just seems like madness. So we went front door, that does wildcard routing. It's also multi-region, so it'll help with our region failover plans that we were cooking up. But the problem now is, right, it strips the IP address. Well, it doesn't X-forwarded for header. The problem with that is anyone could have faked that. So if we allow access to our server, our APIs, we could be lied to about X-forwarded for. So we're now having to work on adding an extra header and service tag based on a network security group that guarantees that X-forwarded for also only came from front door. So we've managed to solve that after a bit of swearing and tin filling. The other thing we annoyingly found out from front door is some of our customers use a client certificate. So when they're talking to, especially when they're authenticating and getting an authentication token, they have a client secret, they have a client ID, but they also use client certificates. So their requests are signed, so we know they can only have come from them. Front door has decided to throw them away and not pass them on to us. So we are not going to be able to use front door to do anything that needs client certificates. And this is a requested feature since 2018 in the Azure forums, and we're hoping they're going to add it. But for the moment, we're probably going to add a service discovery point that is handled by front door, so that whether we're running in, say, Western Europe or Northern Europe, we can tell someone where our authentication server is, on which you can use client certificates. So if we ever move our authentication server between regions, we can point them where to go. So that was a nasty bit of networking horror, and that's caused by the fact that front door is quite a sophisticated product. It's quite doing quite a lot of stuff, and it's heavy duty networking, and they haven't done all the things that you might want. But what you get is something that really can move traffic between different areas of the world based on different rule sets. Signal R we also needed to use because we were trying to put live FX prices down to a browser, and the only way you can stream something like 10 different values per second to a browser is using something like a WebSocket and using Signal R type technology. Or it's the easiest thing. You can use HTTP too now, and that's come in. But the Signal R that you can get from Azure, because Microsoft wrote Signal R, they've supported it really well, is for something like £35 per unit per month, we can have 1,000 simultaneous connections and 1 million messages per day. And the redundancy scaling is built in. So you don't need to worry about CPU scaling or network scaling and everything like that. When I first came to Huddle, one of the first architecture documents and the architecture decision records, which we had called an X360, was to implement Signal R and use it for one of our products. We did it as a single box. When we went to use it more heavily in the product, we decided, right, we need to make this redundant. As soon as you made Signal R redundant, you have to have something called a backplane, which is how Signal R instances can talk to each other. It could be Redis or Service Bus or SQL, and we had to do all that work, and we had to make them into virtual machines in AWS in the end with a backplane that we had to configure. None of that needed with SignalR. You just pay £35 a month, and that's it. You now have 1 million messages a day with 1,000 simultaneous connections, and this absolutely solved our problem. We even found that some of the things we wanted to do after streaming prices, we were then executing trades and saying, hey, we want to trade at that price. We weren't fast enough using HTTP before the prices expire, and we actually use SignalR as part of the API back to commit trades. And it's really reliable, stunningly reliable and easy to use. We also decided to adopt Redis to get some caching. Really nice thing is, I know that when we were at Huddle, we had Redis running on Windows servers. That wasn't the most reliable because it doesn't like Windows really. It would like to run on Linux. By the time we were in AWS, we were in Linux VMs and behaved a lot better, but we were handling Redis clustering ourselves. Now, when you buy it from Azure, it's just clustered. You don't care. It's primary replica duplication. You've got 99.9%, which sounds really good, but it does mean nearly 9 hours of downtime a year. You can spend a bit more, like 10 times more, about £300 a month instead of 30, and you can get 11 minutes of downtime, which is a lot better. But it's a cache anyway, so you should be able to refill it really fast. And AWS has Elasticache for Redis, and Google has a Redis solution as well. So the really nice thing about these, if you actually talk to these stuff as just a Redis instance and you don't care about how it's configured and you're just using it in a generic way, it actually makes it easier to use other providers and have a mix and match in your cloud. The one thing I said was, because we've lost our VMs, we probably haven't got scheduled tasks and things that can do things in the background, but that's where the serverless guys help us out because they invented functions. And one of the things we can do with functions is do timer-based functions as well as HTTP or storage functions. So we can really leverage that, but they do have a minimum time. The cheap one services are only 10 minutes. So we use runbooks. These are limited to PowerShell and Python, and they last about 3 hours. These are little scripts that you just say, hey, run this every day, run this once a week at this time, run it at this time. You can trigger them from events. So you can say every time someone does this, run this runbook. All that kind of thing. So they are more flexible than just a scheduled task on a VM anyway. The really annoying bit is, remember that tick box I said you shouldn't tick that says allow all Azure services to SQL Server? These don't get a known IP address because you don't own them. These are short-lived. They're built, run in a big server farm. So we found that we couldn't actually connect to SQL without ticking the box. But the interesting bit was the message you get back from SQL is a message telling you what IP address it is you couldn't use. So after we did our WTF, we decided, let's have a look at a dynamic firewall connection. So horror of horrors, in our runbook, this is just straightforward PowerShell. In our runbook, we have a standard SQL connection. There we are. Ooh, that's not very thick. I want the highlighter. There, that's better. And a standard kind of SQL connection string all over here. And what we do is we open the connection. We then catch the fact that it's going to have an exception. And it will always have this exception because we haven't got that IP address registered. And then here, we look for where it's going to tell us what the IP address is. We nick the IP address completely out of the error message we get back, and we add a new firewall rule temporarily while we do our operations, and then we move it at the end of the runbook. And just to be safe, just in case our runbook didn't finish correctly and last time, we remove it before we actually create the new one every time. So that's how we evilly, and it's very evil, did a hack in order to get our runbooks to get to our SQL Server. And you'll find a lot of those kind of comments. So what are my conclusions about PaaS? One of the things it's really good for is trial and adopt pattern, the ThoughtWorks idea that we go, what we're going to do is we're going to take something, trial it on a little bit of the product, and make sure it works. And if it's really good, and if actually you can't get past the configuration options and there are barriers to you being able to use it, you can build out your own version. That's a completely acceptable way of handling it all. So you can decide that we use it for a proof of concept, but in the longer term, we could build it out, or you might find it scales enough anyway. So it's a really good way of trialing products and making sure that your architecture actually stands up to scrutiny and the load of your customers. Now, one of the other things, this was a new bit that got added because Ian Cooper was at the quiz last night and used the words illusion of control. When you have your own virtual machines or you have your own sophisticated kind of access to even managed services where they allow a lot more options, so clearly they don't with Front Door because things are shut down. There are things you can't configure in Signal R that you would be if you had your own Signal R box. It is an illusion of control because sometimes if you have the ability to set all the options on your product, especially with things like RabbitMQ and Redis, there are options you should never set on those products in live. There are options that are mutually exclusive, but it will allow you to configure them at the same time. And those kind of things have happened and caused people huge amounts of grief. So just because you think you want to have control doesn't mean you should be given it. So there is an advantage, and it's an illusion because a lot of the time, if you read as Ian was saying, a load of blogs say you should never touch these settings ever in your life, ever, ever, ever. So although those settings are available, you should never use them. Costs. Well, you know what? If you do not have to care about patching, and you don't need to care about disk space, and you don't need to care about scaling of, oh, when these VMs go to this size, we need more VMs, which means we need a new box to host all our VMs on, or all that kind of thing, we can eliminate a tech ops team. There is no tech ops team at Free Market FX. I hate to say DevOps, but what I mean is the developers are quite capable of running the platform as it is, because Microsoft have a tech ops team who are dealing with all the sort of issues that a tech ops team would normally deal with. And you've got to balance. So one of the questions people will have, doesn't platform as a service cost more money? So there is that thing where if you are using serverless heavily, it might actually be less effective than having a managed service to do exactly the same thing. You've got to balance your additional costs against opportunity costs. So what do I mean by that? That is, it may be costing $200 per month to run this service, whereas over a year you would probably be, say, you would have spent $1,000 more than you should have. But if you can deliver that system 2 months earlier and get a client who's going to give you the $2,000 who would have gone somewhere else, a customer, then you ought to actually use PaaS. Get the customer on board, get them happy, and have them as an existing customer. And then you can work out how you might actually move it over. So that opportunity cost and the internal support cost can quite often balance a no-tech a PaaS system. There's also the lock-in myth. So a lot of people would say, but if you use this, this, and this from this cloud provider, you can never leave that cloud provider. Now, how many people use an ORM, right? So to talk to a database, and they said it's important we use an ORM and it's important we do everything generic because we may switch between SQL Server and Oracle, or we may switch between MySQL and SQL Server. Virtually no one ever switches a decision like that. They don't move between one database server and another. And realistically, you're unlikely to move between AWS and Azure in a hurry. And in fact, your costs of trying to be generic on a cloud provider such that you could move probably outweigh the costs of rewriting stuff for a new cloud provider. And you are wasting huge amounts of time and effort in order to do something that will never happen. It's interesting that David Whitney, I saw him give a talk in DDD East Anglia, and he did quite a good. One of the reasons you can configure things in AWS a lot more than Azure is AWS has always seen itself as almost, when it was created, it was put everything as familiar from a data center point of view. So its kind of mindset is it is moving your stuff from a data center into the cloud, and it's never gone for cloud native immediately. A lot more configuration, a lot more ability to change and tinker things, because that's where they were when they started out. Azure did a much more pointy clicky, try and abstract a lot away so that we can actually leverage all the things you could have from a cloud platform. And that was an interesting take that he explained a lot better than I have just done, that explained why there is that difference between the kind of way you look for Azure, the way you might look at AWS. And that goes to the heart of why AWS have done things like fork Elastic Cloud and cut Elastic, the company, out of the equation on their service, which I think is a bit unfair to an open source company, personally. So I do like to think that Microsoft has been a bit more respectful to the open source guys at times. And that's it. So that was my talk on PaaS, how I've experienced it at free market compared to my previous experiences at AWS, which may have not been the kind of most wonderful AWS experience you could have had. If you want to get in touch with me, I'm at Westley L on Twitter, and somewhere I had up, which I accidentally went to at one point, I have put this presentation at Westley L GitHub at Westley L /NDC London 2021 if you want to download it.